Have you ever wondered how water got on Earth? It's a question as old as the human fascination with the skies above and the world beneath our feet. Earth, the blue jewel of our solar system, stands unique for its abundant reserves of liquid water, the elixir of life. Without water, life as we know it would cease to exist, making this question of its origins not just a curiosity, but a matter of existential significance. Yet the answer remains shrouded in mystery. The origin of water on Earth is an enigma that has puzzled scientists and researchers for centuries. Is it a primordial gift, present since the planet's fiery birth, or was it delivered later by icy comets and asteroids? Did it bubble up from the Earth's own depths, or did it drift in from the cold vast reaches of outer space? And so, the quest to uncover the origins of Earth's water takes us on an intriguing journey back in time. Many theories have tried to explain the source of Earth's water. Let's delve into two of the main theories that have been proposed over time. The first one is the primordial theory, which suggests that water has always been here, right from the inception of our planet. According to this theory, water was part and parcel of the dust and gas cloud from which the Earth formed around 4.5 billion years ago. Fascinating, isn't it? Water in the form of ice was mixed in with the other elements that eventually came together and formed our planet. As the Earth cooled down, this ice melted, forming our oceans. Now, let's move on to the second theory, often known as the comet and asteroid theory. This theory proposes that water was brought to Earth later, after the planet had already formed. And who were the celestial water carriers? Comets and asteroids. Yes, you heard that right. Comets, which are essentially dirty snowballs made up of ice and rock, and asteroids that are more rocky in nature but can contain water, are thought to have bombarded the Earth in its early years. This period of intense bombardment is known as the Late Heavy Bombardment, which happened around 4 billion years ago. The water from these comets and asteroids, as per this theory, filled up our oceans. It's like a cosmic water delivery service. Imagine that. But here's the catch. Both these theories are plausible and backed by scientific evidence, yet each has its own set of challenges and unanswered questions. For instance, the primordial theory struggles to explain why Earth's water has a different isotopic signature than water found in comets. On the other hand, the comet and asteroid theory grapples with the fact that not all comets and asteroids have the same isotopic composition as Earth's water. Each theory presents compelling arguments, yet none can definitively answer the question of how water got on Earth. Comets and asteroids have long been considered potential water bearers to our planet. These celestial bodies, formed in the early stages of our solar system, are often referred to as the leftovers of planetary formation. They are frozen time capsules holding clues about the primitive materials that contributed to the formation of planets, including Earth. For many years, scientists have theorized that these icy wanderers could have delivered a significant portion of Earth's water. This hypothesis was based on the fact that both comets and asteroids contain water in the form of ice. When these celestial objects collide with a planet, they could potentially deposit their water content onto its surface. But how do we know that the water on these space rocks is similar to the water on Earth? The answer lies in the unique fingerprint of water, its isotopic composition. Water molecules are made up of 2 hydrogen atoms and 1 oxygen atom. However, not all hydrogen atoms are created equal. Some, known as deuterium, are heavier than others because they contain an extra neutron. Scientists can measure the ratio of deuterium to regular hydrogen in water from different sources, creating a unique isotopic signature. When they compared the isotopic signature of Earth's water with that of comets and asteroids, they found a striking similarity. This provided compelling evidence that these celestial bodies could have played a significant role in delivering water to our planet. However, it's important to note that not all comets and asteroids have the same isotopic signature as Earth's water. This suggests that while some comets and asteroids may have contributed to Earth's water supply, others may not have. Moreover, calculations suggest that the number of comet and asteroid impacts in Earth's history would not have been enough to deliver all of our planet's water. This leads us to believe that while comets and asteroids have certainly played a role in Earth's water supply, they are not the sole source. Despite the compelling evidence, the comet and asteroid theory alone cannot account for all of Earth's water. Another theory posits that water was here from the very beginning, a part of the Earth's formation. This idea, known as the Earth's formation theory, suggests that our planet's water was not delivered by external sources like comets or asteroids, but instead was part of the original recipe that cooked up our world. Let's take a step back to over 4.5 billion years ago. Our planet was forming from a swirling disk of dust and gas left over from the birth of the sun. This theory proposes that some of the tiny particles in this disk were water ice, and as these particles gradually came together, forming larger and larger clumps, the water ice was incorporated into what would eventually become the Earth. But what evidence supports this idea? Well, one piece of evidence comes from deep within our planet's mantle, the layer between the Earth's crust and its core. Scientists have discovered the presence of water in this layer, trapped within the mineral structure of rocks. This suggests that water has been a part of Earth's composition since its formation, rather than being added later by comets or asteroids. Another supporting piece of evidence lies in isotopic similarities between Earth's water and water found in meteorites from the inner solar system. You see, water molecules can be made of different isotopes of hydrogen and oxygen, and the ratio of these isotopes can tell us about the water's origin. Studies have shown that the isotopic signature of Earth's water closely matches that of certain meteorites, suggesting that our water and these meteorites share a common source. While this theory provides a plausible explanation, it still leaves some unanswered questions. For instance, if water was present from the very beginning, why is Earth's surface not completely covered in oceans? And why do we find differences in water isotopes between various locations on Earth? As we continue to explore the mysteries of our planet's water, these are the questions that keep scientists digging deeper, pushing the boundaries of our understanding. The debate about the origin of Earth's water is far from settled. For decades, scientists have been wrestling with theories and counter-theories, each one attempting to explain how our blue planet got its water. Theories that, until recently, seemed to provide some understanding are now being challenged and new possibilities are being introduced. The comet theory, for instance, has been a popular explanation for many years, but recent research is now suggesting that the water found on comets may not match the chemical composition of Earth's water. This has led some scientists to question whether comets could have been the main source of our planet's water. Then there's the theory that water was present when the Earth was formed. This idea proposes that water was trapped in the dust and rocks that formed our planet. But the extreme heat of the Earth's formation process makes this theory problematic. Could water have survived such intense temperatures? Meanwhile, a newer theory has emerged suggesting that asteroids, not comets, might have been the main deliverers of water to Earth. The water found in asteroids is a closer match to the water on Earth, making this theory an intriguing one. Yet, it also raises its own set of questions. Were there enough water-laden asteroids to provide the vast oceans we have today? The debate is intense and ongoing. Each theory has its merits and its challenges, and the scientific community continues to test and refine these ideas, pushing the boundaries of our understanding. With every new piece of research, we gain a better grasp of our planet's history. But for now, the origin of Earth's water remains a tantalizing mystery. As we continue to explore and understand our universe, perhaps one day we will definitively answer the question: how did water get on Earth? Understanding the origin of Earth's water has profound implications. The very essence of life as we know it is housed within this liquid marvel. Unraveling the mystery of how water arrived on Earth could lead us to an understanding of our planet's history and perhaps even its future. But the quest for knowledge doesn't stop at our own blue sphere. It extends far beyond, into the vast expanse of the cosmos. Our understanding of water's origin on Earth could provide a blueprint for the search for life beyond our home. Imagine for a moment a distant planet or moon with the same water-rich conditions as Earth. Our knowledge of water's journey here could be instrumental in identifying potential abodes of life elsewhere. It's not just about quenching our curiosity, it's about finding our place in the broader cosmic context. As we journey through the cosmos, the story of water on Earth may guide us in our search for life elsewhere in the universe.